Okay. Thank you very much, and also nice welcome, nice afternoon from my side, from the side of Böhler International. I have the honor to present today new materials, new tool steels in the application field of cold work tool steels. We call them hard, tough tool steels. First of all, I want to show you today an overview and a short introduction about different applications of cold work tool steels. And then I want to go in more details presenting our new 3 cold work tool steels, K353, K340, and also our K419. When we look to these new 3 grades, there is always the question, why do we need tool steels, new developed tool steels? I think the answer is quite easy. We are the answer to that, because our demands in the technology is rising more and more. That means, let me give you an example for the automotive industry. We are demanding that the consumption of our cars is going down and down. On the other side, the safety of our cars should rise. So how can this be? Only by changing the technologies of materials. And if we have new materials in our cars, we have also the need of new tool steels to process those sheets, those steels. When we have a look to the standards or to the general applications on the cold work tool steels, we see that roughly 30% is used in the cutting and blanking industry, as well as 30% are close to 30% are used in the cold forming industry. A strong part is the industrial knives and also other engineering parts made of the cold work tool steels. Examples from the industry: deep drawing, as you can see here, for forming of sheet materials. Knife industry, very well known to everybody, depending to the applications for recycling industry, plastics, wood knives, paper knives, as well as knives used in the steel industry. Minting and coining industry, very well known to everybody of you. You are paying more or less daily with the Slovenian euros. They are produced mainly from Böhler tool steels, made in Finland as far as I know. As well as the industry for rolls, cold rolls and form rolls. Their demands also very high developed tool steels for different cold forming applications. When we are looking to the requirements to our tool steels, to our cold work tool steels, then we have 3 main properties. On the one side, the wear resistance. On the other side, the compressive strength and the toughness. And important, and getting more and more important, is that we have the right balance of those 3 properties. So only wear resistance is not good enough anymore. Only toughness is also not that what we need. We need the right balance, the right combination of those 3 key properties. Let's look a little closer when we are talking about wear resistance. What does it mean, or how can it be? There are 2 ways of wear resistance. The one is the adhesive wear resistance, or also cold welding known. So that means sticking together of material. This is very, very often the case when we are working or when we are processing very soft materials. Aluminium, copper, brass, austenitic steels, so very soft one. Then we have very often this sticking together called adhesive wear resistance. The other side is the erosion, the abrasive wear resistance. Here, material is disappearing. Here, material is going away, is removed. So that's the field of the wear resistance. You see here the microscope picture how such a wear could look like. The second one, toughness, cracks because of too low toughness, or better to say ductility. Ductility would be the more precise definition. So here, the material, in this case it is a roll, was not ductile enough to keep the stresses they were brought to the roll during the cold work application, and therefore we get chippings and then we get fracture on the tool steel. That's also to avoid. And the third one, called compressive strength. Compressive strength is very, very important by processing strengths, high strength and ultra high strength materials, because the basic of the the strength of the basic sheet we have to process is very demanding to deformations, to plastic deformations, which creates then, here is a process shown, which creates then deformations like seen here, and at the pull-back move we get chippings off. This is the typical problem of too low compressive strength in the tool steel. So it is really the combination of the wear, the toughness, and the compressive strength which we need for long tool life in our today's industries. Böhler developed a lot of materials. To give you a short overview, on that side you see the wear resistance, the measuring of the wear resistance versus the ductility of the materials. And you see three general groups. In gray shown the group of the conventional tool steels. This is that what you can buy according to Werkstoff number. This is somehow the standard existing today. When you read here K110, this is the 2379 tool steel. A very good, very resistant, but very low in toughness, typical tool steel. On the other side, where you read here K600, this is the material 2767. Here we are talking about a material with a very low wear resistance, but with a quite huge basic of ductility. So only good wear resistance is not that what we want, only good toughness is not that what we want. We want to find the compromise, the combination of that. And what I will present you today is an overview, or is more precise, the material K353, a compromise between wear resistance and ductility in the group of the conventional tool steels. About the K340, a ESR remelted tool steel, that means finer structure, more uniform surface use. And finally, the K490 microclean, which is powder metallurgical steel. Powder metallurgical steel, the highest level on the tool steels you can find in the market. That was the view to wear resistance and ductility, conventional, ESR, and microclean products. If we compare those three groups in terms of compressive strength, then we see that the K353 is as a conventional tool steel in a moderate level of around 2,300 megapascal. K340, a so-called ESR material, ISO-dur, is in the level of 2,007 to 2,800 megapascal. And the highest level is on the powder metallurgical material K490. So you see, if we have to process strengths, ultra high strength sheets, they are already at the level of 1,600 megapascal, and so we are definitely wrong by choosing materials with only 2,300 or 2,800 megapascal. Here, the technology shows definitely to use powder metallurgical steels as our K490. Let's have a look to the microstructure. Also, that's quite interesting. Here we are having the microstructure of a conventional tool steel. We see the typical carbide lines, a lot of space without carbide. So this is a typical form of a conventional cold work tool steel. Looking in the middle at the K340, this is the ESR, the electroslag remelted material. Here we see a much better distribution of the carbides. These are the white dots. And the carbide size is also more uniform. So this is the second level of our productions. And the highest level is definitely the K340, the microclean products. Here you see a microstructure, very, very uniform. The white dots are very uniform distributed. That means we get out the really right and uniform properties on this kind of tool steels. And now let's have a look to the details of those three materials I want to inform you today. Let's start with the conventional K353, which is a typical all-rounder material. In terms of the chemical structure, it's an 8% chrome steel with a 0.8% carbon, a few additional carbide bildners like molybdenum and vanadium, as well as aluminum is alloyed here. A very uniform, useful tool steel in the working hardness between 58 and 60 Rockwell C, typical and standard for cold work tool steels, I would say. Easy for heat treatments, nothing special, nothing you have to take care especially. And the results compared to the standards, which is very well known on the market, 2379, are tremendous good. If we compare the toughness, the ductility in the material, we measure that in an unnotched impact energy test. And the K110, the 2379 material, offers a rather low level of toughness. When we talk about K353, the new developed one, we can estimate a roughly 6 to 7 times higher toughness. And toughness is nothing else than safety against cracks, safety in your tool life. If we compare this with the abrasive wear resistance, where the 2379, this is the standard in the cold work tool steel, offers us a level 1, we see that the K353 is going down to roughly 60% of the performance of a 2379. But this is very often good enough. We don't need more. And because of this balance of a very high improved toughness and an acceptable good wear resistance, this K353 offers us a very wide use of this material. It's used in the cutting and punching industry. It's used in the cold forming and coining industry, as well as in the bending industry and knife industry. So a very, very complex all-rounder material for more or less all cold work applications. Jumping to the next material I want to present is our K340 ESR material. This material is performing on the same wear resistance level like the known 12% chrome steel 2379, but is offering a huge toughness level like the conventional 8% chrome steels. So a very nice compromise. And for that material, I just want to show you 3 examples from the praxis. Examples talking about tool life. The first is a roll used in the automotive industry for driving belts, gears, yeah? And this start material 2379, these are examples from our customers, they started with a 2379 material, and after 7,000 pieces, they got cracks. They recognized by far too low toughness for their applications. By using the K340, this new developed 8% chrome steel, on the same hardness level, we could achieve a performance of 22,000 pieces. So that means 3 times higher in terms of tool life results just by changing the tool steel, because the combination of the 3 properties was required here, not only the wear resistance. Another example is coming from the processing or cold forming of low carbon steel with 400 megapascal compressive strength. And when we look here, they tried a couple of materials, 5% chrome steels, very soft, very tough tool steels, as well as the 2379, the 12% chrome steel. The best result was close to 530 parts they could process. Once it was the wear resistance which was missing on the first 2 tests, and once the toughness was missing. So by choosing the right tool steel, having the right balance of toughness, wear resistance, and compressive strength, we got the challenge, we got the chance to go up to more than 7,700 parts, which is compared to the first 530 parts, more than 10 times more. Same process, only a second tool steel used. And the last example of this K340 is coming from the inox industry, also very thin material, 2 millimeters. Inox material has to be processed for different applications, like you can see it here, for automotive industry or electronic industry. And the result was again the same. By using the 2379, we had, after 20,000 parts, already a fracture because of adhesive wear resistance and because of toughness problems. By jumping or by changing to the 8% chrome steel K340, again, the right balance of the properties, we could increase from 20 to 50,000 parts. So in general, we know about all the application fields on cold work tool steel that a K340 developed material offers to you a roughly 3 times longer tool life. And that is what we want. Increase of tool life, because this is the benefit of the production, this is the benefit of the tool user. And finally, let's have a look to this new developed microclean product K490. Material K490 is our newest powder metallurgical tool steel produced in Austria, Kapfenberg. The goal was to set this K490 in the wear resistance level close to the PM23 or M4 types of the powder metallurgical steels you can buy on the free market. But on the similar wear resistance, we set the goal to enlarge the toughness, the ductility level, which is again safety against cracks, prolonging of the tool lives. And this was done, or this could be reached by the chemical composition of a typical 4% vanadium cold work tool steel, 1.4% carbon, and carbide builders like molybden and tungsten and carbon and chromium are as well in the structure. Special for that material is also the alloying of niobium as a tool steel, as a carbide builder. Working hardness 60 to 64 Rockwell C, also very typical, nothing special on that. If we look to the heat treatment, to the tempering charts, to the heat treatment of this material, it's quite easy and very popular because we can work on the typical hardening temperatures like our hot work and cold work tool steels. So nothing special to require in terms of the heat treatments when we talk to our heat treaters. So that's quite easy. And the tempering temperatures also in the typical range of tool steels between 540 and 560 degrees. And you see here the results when we talk about wear resistance. When we are talking about wear resistance, then we are in the level of the PM23 or M4 materials, like you see here on the green column. And we are roughly double higher than the conventional 2379 material. So in terms of wear resistance, we could hold the PM23 level, but in terms of the toughness, we could double and more the level of the PM23, and we could even go to 9 times higher performance on the 2379 material. And that's really the challenge for an all-rounder material. That gives also the very clear hint that we can use it in all the cold work applications we need. There is no application in the market where this K490 cannot be used as a very, very fitting all-rounder material. You see here blanking, cutting, stamping, rolling, cold forming. So really the whole group of cold work applications can be covered by this new microclean powder steel. Yeah, let me show you one example from the praxis more of that material. So that was to process a 2 millimeter sheet material DC04. It was an embossing die, and by the use of the 2379, here is a picture of that, we are really very, very low in terms of the tool life. Less than 100,000 parts could be done, and we got cracks because of too low toughness in the material. Then they changed to a very high alloyed powder metallurgical steel already, but the balance was not good enough to reach more than 500,000 parts. And by using this all-rounder, very tough developed K490, we could increase to more than 2.5 millions or close to 2.5 millions without any cracks. And this is exactly what we have to sell to you, what we have to sell to the tool makers, because that's the benefit for the productions. So summarizing the 3 grades I was talking today is that we have a standard, the 2379. This standard is good for 60 to 70% in the tooling industry, in the cold work tooling industry, no doubt about this. But for the other 30 to 40%, we have really a nice group of tool steels who could really fulfill the requirements. We have the higher toughness and a little lower wear resistance conventional K353. We have the increased toughness and similar wear resistant developed K340 Isodur, as well as we have on the top the K490 as the microclean all-rounder you can buy in the market. With that chart, I would like to say thank you very much for your attention.
Thank you. Please, audience, some questions? Really, no questions? You explained so perfectly all the materials, so but still I have one. You have some customers in Slovenia.
Yes.
Also, which of those tools are used from them, or you prefer to be used from them?
All those tool steels I was talking today are very, very professional and benefitful used in Slovenia. We sell them in the knife industry, we sell them in the tooling industry, we sell them in the fine blanking industry. So it's really a very, very interesting market also for us. Slovenia, a very innovative country, using a lot of new materials, trying a lot of new technologies, and that's why we are also here to present those or to promote more those 3 special developed materials.
Je že kakšno vprašanje? No, še eno vprašanje bi lahko. Izgleda bilo, it was obviously so perfect, all your presentation, so thank you again. And ja, še to, za vprašanja možna, ne, seveda se lahko obrnete tudi na njihov razstavni prostor, tako da tudi tam so vam na voljo še danes in pa seveda tudi jutri. Tako, najlepša hvala. Thank you.
Thank you.